Hi future doctors, welcome to the next class. So we'll see some problems related to gravitational force. So an infinite number of masses are placing each mass small m, placing at 1 meter distance. So 2 meters distance, next one 4 meters and so on. Then what is the gravitational force at origin they are going to ask. At origin they are asking means whenever they didn't give anything we will use 1 kg, 1 kg object. How the gravitational force is going to be coming means, so F naught, gravitational force at origin. Force between this m and 1 kg, G m by 1 square. So this is going to be attracted. So same like this, because of this mass also attract, because of this mass also attract. So always we have to add because all are coming in same direction, plus gm by 2 square plus gm by 4 square and so on. So like that 8 square, like that they will give. So gm is common, 1 plus 1 by 4 plus, this one can be written as 1 by 4 square. Next one 1 by 4 cube, like that it is going to be coming. So next one is going to be 8 square. 8 square, 8 square means 64. So 4 cube, isn't it? Like that it is going to come. Then what is this? Infinite term means sum of infinity term. S infinity is going to be a by 1 minus r. So what is a? Already in basics we have given a is nothing but, let us assume, try to take 1. R is nothing but with sign. This first term is going to be always r. Therefore 1 by 1 minus 1 by 4. 1 by 3 by 4. That is going to be 4 by 3. So in place of this total infinity term, we will write gm into 4 by 3. So 4 gm by 3. So this is the gravitational force at origin. Next, in previous class we discussed already. So if three masses we are taking at three corners of a triangle of each side small a. So what is the acceleration of any one of the mass, they will ask. What is the acceleration of any one of the mass means, first of all, what is the gravitational force acting on any one of the mass? F is equal to root 3 gms square by a square. Again, you should not ask how this equation came. Already we discussed that. Now, how to apply that for the given question means, they ask the acceleration. F equal to any one of the mass is small m. Ma is going to be root 3 times of gm square by a square. So this m and this m will be cancelled. This is acceleration, root 3 gm by a square. This a is distance. You should not get confused. Otherwise L you can take, X you can take, that is your wish. This is how they are going to ask the question. Next, in a circle, in a circular path, two masses are going to be revolving by mutual attractive force, gravitational force. This radius is going to be r, they are going to. So they may give m or m1 m2, that is their wish. So whenever these are going to be rotating, which force is required to rotate in circular path means centripetal force. The centripetal force is provided by gravitational force. What is centripetal force formula? We have three formulas: mv square by r, mr omega square, mv omega. This centripetal force should be equal to gravitational force gm square by, what is the distance? 2r whole square. They may ask velocity, velocity of each mass. Tangent we have to draw if it is rotating anti-clockwise. If they are asking velocity, we will use this formula: mv square by capital R is equal to gm square by 4r square. So 1 m will be cancelled, 1 r will be cancelled. Then v is equal to root gm by 4r. This is velocity. Sometimes they will ask time period. So what is the time period they will ask? At the time mr omega square. So mr omega square equal to g m square by 4r square. So from this we can cancel one m. You can send this one right side, omega square is equal to gm by 4 r cube. So then omega is root gm by 4 r cube. In place of omega, what we can write? 2 pi by t. So like that, you are going to get time period. Sometimes this mass, one of the mass will be at center, only one mass is going to be revolving. In that case also, we will do like that. So here, mass is going to be revolving, one mass is at center, another mass is going to be revolving in a circular path of radius r. Again, to move object in circular path, centripetal force. So that is equal to gravitational force. What is centripetal force formula means? Again mv square by r, mr omega square, mv omega should be equal to gravitational force, gm square by, now see, this is going to be r square. Small change here, in place of diameter 2r whole square, here you are going to get r square. Again same. So if they are asking velocity, mv square by r equal to gm square by r square. One r will be cancelled, one m will be cancelled. So v is equal to root gm by capital R. So if they are asking time period, we will use this equation. Same question they will ask like this. Now three masses m, m, m like this. Three masses are going to be taken place. At the time, these three are going to be revolving. So whenever these are going to be given like this, one small condition how they are going to give means, so from center to those masses, it should be same radius, same radius, same radius. Now this is going to be triangle, it is going to be made, isn't it? Now this is small a equilateral triangle they will give. Now you should get the relation between this capital R and small a. So this is about small m. So what is the velocity? So already for two masses we did, for three masses, for four masses also we will do. This is going to be a square of each side small a. This is going to be capital R radius. For all this simple logic, always centripetal force equal to gravitational force. Now what is the gravitational force on any one of the mass? In case of triangle, gravitational force is equal to root 3 times of gm square by a square. A is distance between two masses, isn't it? This gravitational force should be equal to, so if you want velocity of one of the mass, then centripetal force mv square by capital R. Now you should get relation between capital R and A. Already we have given. For triangle, if it is A. So from center to the small r we said, here it is going to be capital R. So what is the small r we said? A by root 3. Here you have to write, so mv square by A by root 3. So once you write A by root 3, so root 3 gm square by A square equal to, next one, so m v square by means root 3 mv square by small a. So these two root 3 will be cancelled, one a is going to be cancelled, one m is going to be cancelled. So v is going to be root gm by a. This is the velocity. If they are asking time period, means root 3 gm square by a square, gravitational force should be equal to, which force we are going to write? Centripetal force mr omega square. Root 3 gm square by a square is equal to mr omega square. Again, what is capital R? Capital R is going to be a by root 3. We have to take. Again, you can substitute here a by root 3. You are going to get the answer. So root 3 gm square by a square equal to, so m, in place of capital R, what we can write? A by root 3 omega square. So then you can solve, you will be getting time period. So in this case, if they are asking velocity, so what is the velocity of each mass and what is the time period? So in square we give. In square, what is the resultant gravitational force? So gm square by a square. So 2 plus 1 by root 2 something we give. Root 2 plus 1 by 2 or 2 plus 1 by root 2. Isn't it? This one only we got. So you can cross check. So this one should be equated for either mv square by r or mr omega square. Isn't it? This one you can cross check once, root 2 plus 1 by 2, otherwise 2 plus 1 by root 2. Because if you made mistake here, you won't get the answer. Here I remember root 3 gms square by a square. 90% root 2 plus 1 by 2 only. So resultant gravitation. You cannot calculate here what is the resultant gravitational force by taking like this. You should remember. Therefore, we have discussed all these previously, isn't it? So therefore, it should be very, very important to remember all the formulas previously what we discussed. This is how they are going to ask on gravitational force problems in competitive. I hope you people understood. Thank you.